Well, hello again, guys. Welcome back to GT Algebra 2. So we are going to move into another really big day that's going to kind of come back through every single unit we do throughout this year. Now, there is a Desmos activity that's going to go through this visually, I think a lot better than what we're about to do algebraically. But what we're about to do is really look at the math behind why your graph does what it does with these different transformations. Now, depending on the structure of your class, you may do the Desmos first, you may do the Desmos after. There is an optional video that kind of goes through that Desmos activity to kind of show you how to use it and get used to it. We're going to use that a lot this year, so make sure you understand kind of how to use it. But really, it's going to show you visually what's happening here a little bit better. So what we're going to do is actually look at the algebra behind what's happening. So when we talk about transformations, basically, I think the example we use in the Desmos is parabolas, all right? You really only have one parabola. That parabola is the parent function, okay? Y equals x squared. Every other parabola you could possibly have is just a transformation of that parabola. You can reflect it, you can shift it, you can stretch it, you can compress it, but you are just transforming that one parabola. So what we're going to do is we're going to look at transformations for basically any function. So we're going to start by looking at it algebraically. So what I have listed here, these are the points that are on this given graph right here. So what we're going to do to start, the first transformation is f of x plus 4. So if you've already done the Desmos, you'll know what that does, okay? But let's look and see algebraically. What that means, f of x means y. So when x equals negative 1, if I do f of x plus 4, that means I take the y coordinate and I add 4. Well, negative 2 plus 4 is 2. Right? When x is 1, I take the y coordinate, I add 4, I'm at 6. Y coordinate, add 4, y coordinate, and add 4. So the new points are negative 1, 2, 1, 6, 3, 2, and 5, 6. So I'll go ahead and plot those points, and then you'll be able to see, again, kind of what that Desmos shows you visually, what this graph actually does. It's the same shape, same size, but just shifted up 2. Up 4. So now let's look at horizontal. And this is the one that kind of throws some people off because your horizontal stuff tends to be backwards. So what we're going to do is we're going to look at y. Okay? Well, the w, we're going to look at y, not the letter y. All right. So what's happening here? We are not changing f of x in any way. What this says is f of x minus 2. So in order for this to have a y value of negative 2, okay, the x value of negative 1, if I plug in negative 1 for x, I'm not actually doing f of negative 1 anymore. I'd be doing f of negative 3. I don't know what f of negative 3 is. It's not given. So what I need is I need to find what can I plug in for x that's going to make that negative 1. Because I know f of negative 1. F of negative 1 is negative 2. So in order to get that y value, what x would have to go here? And the x that would have to go there is a positive 1, because 1 minus 2 gives me negative 1. And f of negative 1 is negative 2. All right, let's go to the next one. Again, I want this to be f of 1. In order for it to be f of 1, the x value that would have to go there is 3. Because, again, if I plug that in, f of 3 minus 2 is f of 1. F of 1 is 2. All right, let's go to our next one. In order to get the x value of 3, I would have to plug in 5. In order to get the x value of 5, I would have to plug in 7. So the new points on my graph are 1, negative 2, 3, 2, 5, negative 2, and 7, 2. And you can see same shape, same size, but that graph has been shifted to the right 2. So that's kind of why that horizontal stuff does what it does. All right, looking at the next one, doing both transformations. Now what's nice about these transformations, horizontal transformations will affect the x-coordinate. Vertical transformations will affect the y-coordinate. You don't have to worry about them going back and forth. One affects the one and one affects the other. So let's start with the y-coordinate. That's a lot easier, okay? Negative f of 1/2 x. So basically, we're taking the y-coordinate that we have, we're making it negative. Pretty easy. Vertical transformations are much easier. Well, now let's look at the horizontal transformation. So in order to get this x value, in order for 1/2 x to equal -1. The x value I would have to plug in is 2. All right, looking at the next one. In order to get this to be 1, in order to evaluate, again, I want that to be f of 1 on the inside, then I would have to plug in, sorry, that should have been a -2. Okay, sorry, so in order for this to be 1, I would have to plug in 2, because 1/2 times 2 would give me 1. All right, I want this to be 3. Okay, so in order for that to be 3, this would have to be 6, because 1/2 times 6 is 3. In order for what's inside here to be 5, the x value would have to be 10. So I'm plotting the point -2, 2, 2, -2, 6, 2, and 10, -2, which is way off my graph. So you can see, even though there's a 1/2, that has horizontally stretched this graph. The vertical height has not changed, but the distance from left to right has gotten wider. So that is a horizontal stretch. This graph also has been reflected over the x-axis because it's been flipped up and down. All right. Now this box is really just going to sum up all these transformations. You are going to see this box in every unit but systems. It will just keep coming back up at every function we do. So get used to it. You'll get tired of it. So f of x minus h. Okay, f of x minus h is a shift to the right. F of x plus h is a shift to the left. F of b times x, that depends on the value of b. So if b is bigger than 1, okay, 2, 3, 7, 12, then that is a horizontal compression. And I will tell you guys right now, the most missed transformation is this one right here. And it's because of that kind of backwards mentality. Okay, if 0 is less than b, if b is in between 0 and 1, 1/2, 3/4, 2/3, etc., that is a horizontal stretch. And then finally, f of negative x, that is a reflection over the y-axis. And you're going to see me use that in shorthand a lot, just because I don't like to write the whole word reflection. But an r with a little sub y, that's reflection over the y-axis. And I'll tell you what, I'll write it out the correct way at least this time for you. Okay, so these are all of the horizontal changes. So you'll notice all of the horizontal changes happen inside these parentheses. It's going to be true when we apply them to functions. Algebraically, what's actually happening to your points? These are all changes to the x-coordinate. Shifting right, you are adding that h value. Shifting left, you are subtracting that h value. You are dividing by that b value, so 1 over b, I don't know why I wrote h. So 1 over b times x, or you're making that x-coordinate negative. So algebraically, that's what you're doing. Everything over here in the right box, these are all your vertical changes. So again, everything that's happening outside of the f of x, okay? You're actually applying it to the y-coordinate. These are all changes to the y-coordinate. This is a shift up. This is a shift down. This is a vertical stretch. Whoops, assuming that a is greater than 1. If a is in between 0 and 1, so something again, 1/2, 1/5, 2/3, that would be a vertical compression. And then a negative on the outside there, that is a reflection over the x-axis. And the second most missed transformation is probably the difference between these two. It gets confusing, I think, because reflecting over the x is actually changing the y-coordinates, and reflecting over the y-axis is actually changing the x-coordinates. So that gets flipped sometimes. That's probably the second most missed transformation. So again, what's happening here is we're changing the y-coordinates. We're adding k, we're subtracting k, we're multiplying by a, or we're making the y-coordinate negative. Now, each of these on their own is pretty simple. Once you start combining them together, they can get a little bit tricky. What's nice, again, horizontal and vertical really are separate. Horizontal affects your x's, vertical affects your y's. So if you have one horizontal change and one vertical change, it doesn't matter what order you do them in because one affects x and one affects y. But if you have multiple horizontal or multiple vertical transformations, you need to be careful. There's a lot of different strategies you can use here. Vertical tends to be a little bit easier. You multiply first, okay? You multiply first, you add and subtract second. With horizontal, you can do the same thing, but you need to do an extra step first. So what I'm going to do 95% of the time, let's say I have both a horizontal transfer or compression and a shift, something like f of 2x minus 4. If I have something that looks like this, I'm actually going to take whatever is in front of this x and rewrite it by factoring it out. And rewrite it this way. And I'm going to do that for a lot of different reasons. One, this allows me to keep the same order with vertical. It allows me to multiply by 1/2 first and then add 2. That's the one reason I like it. The second reason, once we start talking about things like a vertex or how it changes to our 0, 0 point, by writing it in this form, it makes your vertex or your point of inflection or things like that very, very clear. So this is a really good step for that. The other reason, when you guys get into pre-calc, you start looking at trig graphs, you're going to have to factor out that value as well to kind of get in the habit of seeing your different parts of your trig graph a little bit of a different way. So really helpful, anything that's in front of the x here, factor it out because that'll make, again, this value look a little bit different, but it's going to be way more helpful for us when it comes to graphing. Now, you don't have to do that. It just changes the order that you apply those transformations in. So let's go back to that example. Let's say f of 2x minus 4. So really, the order you apply horizontal transformations in is basically the order that you would undo what's here, the order you would do to get the x by itself. So in its current form, you would add 4, then to get x by itself, you would divide by 2. So that works, okay? If I factor this out, it just changes the order I apply those transformations. Now, if I were to want to get x by itself, well, the first thing I would do is divide by 2. After I've divided by 2, I would add 2. It's still going to take me to the same place, okay? Both of those methods will still give you the same answer. It's just a matter of the order you're getting there. And again, I prefer factoring out. I just think it has more practical applications. It's not wrong if you don't, but to me, it's easier. All right, so let's apply this. Before we get to graphs, we're going to apply this just to a single point. Some of these will be pretty simple, okay? So we're going to, first of all, we're also going to list what the transformation is. So f of negative x, that's a horizontal transformation. That's a reflection over the y. That means my x-coordinate becomes negative. And that's it. So 2, 3 under that transformation becomes negative 2, 3. The reason for that, if I plug in negative 2 for x, it's f of 2. f of 2 is 3. All right, next one. 2 outside. That's a vertical stretch. Does not affect my x-coordinate. Multiplies my y-coordinate by 2. All right, next one. That is a shift to the left 7. We're going to subtract 7 from our x-coordinate. Does not affect my y. Next one, again, one of the most missed transformation. It is a horizontal stretch, not a compression. Because what we're going to do is multiply, we're going to divide by 1/3. And when you divide by 1/3, you're multiplying by 3. So I'm going to take the x-coordinate, multiply it by 3, which gives me my new point of 6, 3. All right, next one. We've got 2 transformations, but again, pretty simple because one of them is horizontal and one of them is vertical. The horizontal transformation, I'm going right 1. Vertical transformation is up 3. So that means I'm going to take my x-coordinate and I'm going to add 1. I'm going to take my y-coordinate and I'm going to add 3. Again, on the next one, there's 2 transformations, but it's still pretty simple because one's horizontal and one's vertical. The vertical change, we'll do horizontal first. This is a horizontal, and be careful, compression. And then that reflection, that's a reflection over the x-axis. It's a vertical change. So that means I'm going to take my x-coordinate and divide it by 2. I'm going to take my y-coordinate and make it negative. All right, next one is when we finally have multiple transformations on the same coordinate. All right, let's list those transformations first. What affects the x is this right here. So left 2. What affects the y are both of these values. With vertical, we're going to multiply first. So I would do my vertical stretch followed by a shift down 4. So that means I'm going to take my x-coordinate, subtract 2. Then I'm going to take the y-coordinate. I'm going to multiply it by 3 and then subtract 4. So 3 times 3 minus 4 is 5. All right, and then the last one, we've got a little bit of everything. All right, so let's go ahead and let's list our transformations. I'm going to factor out this -2. You can still get the right answer without doing it. It's going to change your order, but again, I just think it's a good habit to get into, and it's going to make some things down the road a little bit easier for you. All right, so let's list those transformations. Horizontally, I have a reflection over the y. I have a horizontal compression followed by a shift to the left 2, based on the way I wrote this. Now again, you could say I have a shift to the right 4 followed by your horizontal compression and reflection over the y. These two transformations, we don't really need to worry about the order because they're both multiplying. We're just multiplying by a -2 or -1/2 at the same time. All right, let's look at vertical changes. I've got a reflection over the x followed by a shift up 2. So let's go ahead and apply those transformations. So the x-coordinate, I'm going to reflect over the y and compress horizontally. That means I'm going to multiply by a -1/2. So that gives me a -1. Oops, sorry. Then after I do that, I'm going to shift left 2. So I'm going to take my x-coordinate. Let me write this out for you. I'm going to multiply it by a -1/2. Then I'm going to subtract 2. That's what I'm doing to my x-coordinate. So that gives me -1 minus 2, which is -3. The y-coordinate, I'm going to make it negative, and then I'm going to add 2. So -3 plus 2 gives me -1. Now again, you can check this answer. If I, or at least with your x in particular, if I take -3 and I plug it back into this original, it should give me what my original x was. So -2 times -3 is 6. 6 minus 4 is 2, which was my original x-coordinate. Again, let's say you didn't follow that order. Let's say I took that point, I've added 4, and then I divided by -2. I still get the same thing. Okay, I still end up with the same answer. It's just a different way of getting there. All right, so what we're going to look at now is actually applying these transformations to a graph. So on this graph, what we're going to do is first identify what that transformation is. So on this first one, there's both a vertical change and a horizontal change. That horizontal change, that's a reflection over the y-axis. That vertical change is a vertical stretch. So what I'm going to do is I'm going to just take one point. So I'm going to take this -3, 0 point. I'm going to reflect it over the y, and then I'm going to multiply the y-coordinate by 2. Well, that 0 times 2 is still 0. Then I move to the next point. Reflect it over the y, multiply the y-coordinate by 2. Well, that's going to move it up to here. And then I'm just going to follow that same pattern for every single point. So it's really what we just did. It's just doing it to multiple points on your graph. So take this point, reflect it over the y, and then multiply it by 2. Again, you're multiplying the y values by 2. All right, 0, 0. 0, 0 is a really nice point because it's only affected by shifts. Stretching it, reflecting it, compressing it does not affect 0, 0. So 0, 0 is still 0, 0. All right, let's take this point here. Let me use a different color now. I'm going to reflect it over the y. I'm going to stretch it vertically. So I'm going to multiply the y's by 2. And then I'm going to take my last point, reflect it over the y, and then stretch it vertically. Multiply the y's by 2. So that leaves me with my graph, which is going to look something like this. So again, what you can tell is this graph has been flipped. Okay, it's been reflected, it's been flipped horizontally, and that graph also has, if you look at the height of that graph, okay, the overall height of that graph has changed, it's doubled. The horizontal width of that graph is still the same width as the original graph. All right, on the next one, we've got multiple transformations again. But again, let's look at what affects the x and what affects the y. So what affects the x here? We're shifting to the right one. Then what affects the y? We are reflecting over the x-axis, followed by a shift of 2. So we're just going to apply those transformations to each point. So I'm going to take this point. I'm going to go right 1, reflecting it over the x, still has the same y coordinate. Then we're going to go up 1, 2. And there's my new point. All right, take my next point. Let's go right 1. Then I'm going to take that point. I'm going to reflect it over the x. And then I'm going to shift it up 2, which puts it actually back where it was. And again, just do the same thing over and over again. Take this point, right 1. Okay, after right 1, reflect it over the x. Reflect it over the x, then go up 2. Let me erase all those others that are in the way. This one's a hard one to show on video. Sorry, guys. All right, take my 0, 0 point. All right 1, reflect it over the x, up 2. Take this point. Right 1, reflect it over the x, up 2. Last point, right 1, reflect it over the x, up 2. And there's my graph. All right, last one. Again, with multiple horizontal transformations, you can go about this 2 ways. You can factor out that 2, or you can just make sure you reverse your order. I'm going to factor out the 2. I think it's just easier. So what that means is I have a horizontal compression followed by a shift to the left 1. Vertically, I'm shifting down 1. So horizontal compression, we'll do that first. So I'm going to take this x value, I'm going to compress it. I'm going to cut it in half. That puts me at 1.5. Then I'm going to shift it left 1. So left 1 puts me here. Then I'm going to take the y's, and I'm going to go down 1. Now let's go to my next point. All right here. Horizontally compress it. So we're going to divide the x's in half. That puts me here. Then I'm going to shift it left 1. That puts me here. Then I'm going to shift it down 1, here. All right, next point. Okay, cut the x's in half. Shift it left 1. Shift it down 1. All right, 0, 0. Cut it in half, still 0. Left 1, down 1. Okay, next point. Take the x's, cut them in half. Left 1, down 1. And then your last point, take your x's and cut them in half. Left 1, down 1. So there is your squished graph. Now again, it may look like this has some sort of a vertical compression. The actual height of this graph is still 1, 2, 3, 4 units tall. The original graph was 1, 2, 3, whoop, bad counting. Starting from here, there we go. Missed my point. All right, 1, 2, 3, 4 units tall. Okay, so the height of this graph has not changed. That's the difference between that vertical and horizontal change. All right, so the last thing we're going to do is we're going to look at how to actually apply these 2 parent functions. And this is what we're going to do throughout the year. So today, we're really just going to introduce what these parent functions are so you can be familiar with the names and the equations. Most of these we're actually going to see second semester. So I'll tell you right now, this one, this one, this one. And those ones we're all going to see second semester. All right. But for now, we're going to go ahead and look at what those are so you can see kind of how those transformations look to an actual function. That's a lot of what we're going to spend our time on this year. So the constant function, I'll write it up here so I have space for the graph. It's just a line. Okay, f of x equals some number. That is just a horizontal line. The linear parent function is f of x equals x. And if you remember, the linear function looks like this. Quadratic parent function you also saw in Algebra 1. All right, f of x equals x squared looks something like this. Absolute value is one we're going to do actually here pretty soon. The equation is just those absolute value bars. So it's going to look like a V. It's probably one of the easiest ones for most people to remember because absolute value begins with a V. Cube root, it's f of x equals the cube root of x. It's going to look something like this. Cubic, f of x equals x cubed. It looks like this, like a little squiggle. Square root, f of x equals the square root of x. So you'll notice in these equations what's pretty common. All these equations are just the simplest form of the equation you can possibly get. That's what the parent function is for these. The graphs, the shape of the graph, don't worry too much about that. Again, each unit we're going to do these, we're going to review them and go over them. For now, it's just getting you a little bit of exposure to what they look like. Rational is 1 divided by x. And this one's going to look very different. It's going to be a very special graph when we get there. Exponential, you've actually already seen. What's weird about exponential, though, is that the actual base of the exponent could actually be any different number. What's key about the exponential function is that the exponent is the variable. And you saw this one in Algebra 1. It looks something like this. And then the last one is the log equation. And again, you don't know what logs are yet, but we'll get there. And that graph is going to look something like this. And it actually will have a vertical asymptote. So those are the parent functions we're going to look at this year. Like I said, some of these you are not going to see until next semester. But a lot of these, constant you should already know, linear you should already know, quadratic you should already know, and then absolute value we're about to do. So we'll spend some time with these throughout the year. Now the reason I want you guys to see those is so you can understand how these transformations look in an actual function equation, as opposed to just using function notation. So what you'll notice, every one of those graphs has kind of its own form of parentheses, okay? Sometimes those parentheses are your absolute value bars. Sometimes those parentheses is what comes after the word log. Sometimes it's what's under a radical. Sometimes it's what's in the exponent. What's being squared, what's being cubed. So every function has its own form of parentheses. So what we need to do then is identify what's a horizontal change and what's a vertical change. Well, on this first one, let's first identify the parent function. This one is absolute value. Okay, it has those absolute value bars on it. The horizontal transformations are inside those parentheses, which in this case is right 3. What's outside is a vertical change. Multiplication is a stretch, so this is a vertical stretch. All right, looking at the next one. X is being cubed, so this is the cubic function. What's inside your parentheses is your horizontal change, so left 1. Vertical changes, we have a reflection over the x and a shift down 4. Okay, algebraically here, what's happening with these? All right, let's think about this. The parent function is f of x equals x cubed. I'm saying that this has shifted left 1. That means I'm saying f of x plus 1. If I replace x with x plus 1, this is what I end up with. If I take f of x and I make it negative and I subtract 4, this is what I end up with. So again, algebraically, that's what it looks like when applying those transformations to that parent function. All right, the next one, that's square root. What's under the root is your horizontal change. So in this case, I have a reflection over the y. What's outside the root, that's your vertical change. That is down 5. And the last one is log. Okay, that's the log graph. What's inside your parentheses is the horizontal change. Remember, this is backwards. Okay, this is a horizontal compression. Then what's outside the log, those are your vertical changes. Reflect over the x and up 7. right, so the last thing we're going to do is just we're going to write some of these out. Again, just getting you guys kind of practice. What we're doing here, this is really going to come back in every unit. You'll see this kind of each time we do a new graph and a new function. So now it's really just trying to get you guys introduced to this concept. So starting with absolute value. So what it's telling me to do is taking the absolute value parent function. And I'm going to apply the following transformations. We're going to shift it to the right 5. Well, that means f of x minus 5. We're going to vertically stretch it by 3. And we are going to reflect it over the x-axis. So algebraically, that's what I'm doing to this function. So x gets replaced with x minus 5. The entire function gets multiplied by negative 3. So that is my transformed function. Now, later in the year as well, we'll talk more about order. But again, we're trying to get familiar with these transformations right now. All right, this is the quadratic parent function. A shift up 2 would be f of x plus 2. Vertically compressed by 1/4 would be 1/4. Shifted left 6 would be f of x plus 6. So that means my equation would be 1/4 x plus 6 squared plus 2. Now again, I will tell you, the order you apply these transformations in matters. It does not state the order specifically on here, so we don't need to stress about it for now. We'll get into that later, though. Then the last one, square root. There's my parent function. I want to shift it up 4. I want to horizontally stretch it by 2, which means I need to put a 1/2 in my parentheses. I want to reflect it over the y-axis, so I need a negative. And then I also want to shift this graph left 3. I should have left some more space. Sorry about that. Again, it does not talk about the order, okay? So I'm going to go ahead and just do 1/2 x plus 3. If it talked to order, then you can maybe have some parentheses there, but we're not getting into that quite yet. We're just listing what those transformations are. So this would be the square root of negative 1/2 x plus 3. The plus 4 is outside the square root. Again, the biggest thing with these transformations for now to understand, what's inside is horizontal and backwards, what's outside is vertical. And that's really the thing that's going to keep coming back. All right, so that is your second big day of content. Again, the reason these first few days are so long is just that these are the things that are going to come back over and over and over again throughout the year. So we really need to be comfortable with them because, again, you are going to see these throughout the year with all the different graphs that we're going to look at.